Hey everyone, in this video we will understand a famous overflow problem or the overflow bug problem in the binary search implementation. So actually this problem of the overflow, it was undetected for nearly 20 years, okay? And nobody was able to detect this error, okay? And this overflow bug was also present in the binary search implementation in the Java, okay? Java utils arrays contains the Java binary search implementation, okay, as a library. And this problem of the overflow was reported to the Sun Microsystem, and finally it got fixed into 2006. Okay, so basically we are going to understand in this video what is this overflow bug problem in the binary search and what are the different solutions that we can take to implement the binary search avoiding this overflow. Okay, so in the previous video I have already discussed what is binary search and how binary search actually works, and I have also implemented binary search using the iterative and the recursive solution. If you have not watched those videos, you can find the link of those videos in the video description below. Okay, so do watch them before understanding what is the overflow bug problem in the binary search. Okay, so now let's start with the video. So basically this was the iterative algorithm that we have discussed in our previous video for the implementation of the binary search. So we were taking the two pointers, low and high. Okay, so low was pointing to the 0th index and high was pointing to the last index. Okay, so let's say we have this array of, you can say, 18 element from 0 to 17 index. Okay, so basically we were repeating these steps again and again, okay, till low is less than high. Okay, or you can say low is less than equal to high. Okay, so basically we were quickly finding the midpoint, okay, between the low and high. Okay, and then we were checking whether our key element is equal to the mid element or not. If it is not equal, okay, then we were either incrementing the low pointer or the right pointer. Okay, so we were changing the, you can say, low and high. Okay, and if it is equal to the mid element, okay, then we were saying, okay, our key element is present, and we were just returning the true. Okay, and if by running whole program this low crosses the high, okay, that is this condition is never true, then we were just returning the false. Okay, so this was the iterative implementation of the binary search. Okay, same goes for the recursive approach. Okay, so basically there is a problem in this line, that is the mid equal to low plus high by 2. Okay, and the problem is the overflow problem. Okay, let's understand what is this overflow problem with this mid calculation. Okay, and let's see what is the solution of this. Okay, so let's take an example. So let's say we have an array, okay, which contains total 100 elements. That is array of size 100 and index start from 0 to 99, right? And for this example, let's say we have unsigned int, okay, unsigned int data type, and the size of unsigned int data type, let's say for this example, is 1 byte. That means 1 byte is equal to 8 bits. So that means from 0 to the power 8 minus 1. Okay, so that means 0 to 255. This will be the range of the unsigned int data type. That means the numbers like 0, 1, 2, and the last number 255. Okay, this number can only accommodate in a variable of type integer. Okay, unsigned integer. So let's say this mid, okay, this mid we have declared as unsigned int, okay, while we are implementing this binary search. Okay, so that means inside the mid, values from 0 to 255, they can only accommodate. Okay, if we store any value, let's say 259 inside mid, okay, then mid will not be able to accommodate 259 inside it. It will like store something else. Okay, so basically this I have explained in my data type videos in the C programming, that if we store the larger numbers than the range of a particular data type, then what can wrong happen. Okay, so let's focus here. So just for the time being, you can just keep in mind that if you want to store a larger value inside a particular data type more than the range, then it will not store the correct value. Okay, it will store some wrong value inside it. Okay, and the compiler will not be giving any error for this. Okay, compiler will actually compile your program, but at the runtime, okay, during the execution of your program, your answers might go wrong. Okay, now let's assume that we have written this program, okay, in any of the language, and let's say this low and high, they are of unsigned int data type. Okay, because they cannot be negative, so we have taken the data type as unsigned int, and mid is also of unsigned int data type. Okay, so basically when this while loop will start, then it will be 0 less than equal to your 99. Okay, so it is true. So now you will calculate the mid. So basically mid will be 0 plus 99 by 2, right? Now low and high both are of unsigned data type, right? 0 plus 99 will give me first 99. Okay, and 99 can you can say adjust inside the unsigned int data type, because the range is 0 to 255 and 99 comes inside this range, right? Now 99 by 2 will give me 49, right? So this is the, you can say, midpoint. Okay, so till now everything is okay. Okay, this 49 can adjust inside the mid, because mid can largely store a number 255. Okay, and 99 is coming inside this range, so everything is fine till this point. Now next time, okay, after running this code, next time when we will come here, so what will happen? So let's say your number is lying somewhere here. Okay, the key element is lying somewhere here. Okay, so what will happen after this execution? Your low pointer will change. Okay, so let's say what will happen according to this code, low pointer will come here, right? Okay, now in the next run of this code, here what will happen? You will add 50, okay, plus 99, right? So 50 plus 99 by 2. Now 50 plus 99 will give me 149, right? Okay, so 149 is again between this range, so everything is fine. So basically 149 divided by 2 will give me 79.5, and I am taking the floor. Okay, so it will give me 79. Okay, so everything is fine here. Okay, so basically there is no overflow type of problem here. Now let's take another example. So let's say your array size is 241. Okay, that means your array is starting from 0 to 240. Okay, now what will happen? For the first time when we run this code, low will be like 0 and high will be 240, right? So for the first time when we will find the mid, so mid will be 0 plus 240 by 2, right? So 0 plus 240 is 240. Again 240 is between this range, okay, by 2, 120. So 120 is okay, because 120 can come inside the unsigned int, right? Okay, so mid can store 120, okay, correctly. Now for the second time what will happen? So again let's assume the key element is somewhere else. Okay, so your low pointer will actually change. Okay, low pointer will come to this point 121, that is mid plus 1 by this line. Now next time when we will run this code, okay, again when we will come here, so now low is 121 and high is 240, right? So 121 plus 240, it is 361. Now here is the problem. Okay, and what is the problem? So basically 121 plus 240 is 361. Okay, so unsigned int plus unsigned int, okay, it will give me a answer. Okay, unsigned int data type. Okay, so 361. Okay, I will be like taking this 361 as a value of unsigned int data type. But here you can see unsigned int data type, okay, for this example is of 1 byte, and it can store only numbers from 0 to 255. But 361 will go out of this 255, right? So that means this value is out of range of this data type. Okay, so basically at the run time of your program, 361 will not be calculated by the addition of these two numbers. Okay, instead of 361 I will get some another number. Okay, basically we will get something like 105. Okay, you need not to bother about this like 105 or what number we will get, but here you have to keep in mind that when you are getting a number out of the range of this unsigned int data type, then you will not get actually the correct answer, because 361 cannot be adjusted into a variable of unsigned int data type. Okay, so basically you will get some another value. Okay, and this, let's say 105, okay, if you get by the addition of 121 plus 240, which are of unsigned int data type, this value 105, okay, it is wrong value. And if we do half of this, okay, then it will be 2 5 are 10 and 2 2 are 4, okay, point something, so it will be nearly 52. Okay, so your program will give you 52, but you should not get to 52, right? You should get 180.5. okay, that is 180. Okay, this is the correct answer. Okay, after you calculate this mid using this formula, right? But you are getting 52. So basically this is the problem of the data type, right? Your answer of addition of these two numbers cannot adjusted into the unsigned int data type. Okay, so basically your program will give you the wrong answer. Okay, it may say your key value is not present, although your key value may be present inside your array. So basically how to deal with this overflow problem, right? I hope you have understood that what is the problem. Okay, problem is that we are adding the numbers, okay, and after adding these two numbers, okay, we are getting a value which is out of the range of the unsigned int data type, which cannot be adjusted inside the mid. Okay, now the same problem can occur for the other example also. For example, you have unsigned int data type, let's say it is of 2 byte. Okay, that means 0 to 65535, and you know how it came. It is 0 to 2 byte is 16 bit. Okay, to 2 power 16 minus 1. This can be the range of the unsigned int if it is of 2 byte. let's say your array is of size 60,000. So your array will have 0 to this index. This will be the last index. Okay. So again, for this example, okay, again you can have the overflow. Okay. For the first time, there will be no overflow, because if you add 0 plus 599, okay, it will be this one. Okay. And this can be adjusted inside this inside in data type. Okay. So by 2, this value will also be inside this range, right? But for the next time, okay, when you do mid plus 1, okay, by this example, okay, what will happen? Let's say you do low is mid plus 1. So mid plus 1 is 30,000. Now 30,000, when you come next time, 30,000 plus high is this one. Okay. So when you add this two value, it will come out this. Okay. And this 89,999, it is actually a very large value which cannot be, you can say, adjusted inside a unsigned int data type. Okay. So basically this will give me some another value, and divided by 2, it will give me the wrong mid value. Okay. And so I have got the wrong mid value, right? So this is due to the overflow. Okay. Here, by adding these two large values, I was getting a result that was not getting fit inside the particular data type. So what is the solution of this, you can say, problem of overflow? So one solution is you just increase the size of your data type. Okay. You can take like unsigned long int. Okay. So that you increase the range of this mid variable. But the same problem can occur, let's say, if your array is again large, so that can also come, you can say, out of the unsigned long int data type. Okay, that can surpass, okay, or that can cross the range of the unsigned long int data type also. So let's see the second solution, or the another solution other than changing the, you can say, data type. Okay, so what is that solution? So basically, to understand the solution, let's take the previous example again. So let's say unsigned int is of 1 byte. Okay, and the array is from 0 to 240. Okay, this array. Now for the first time there was no calculation error. Okay, but for the second time, due to this 121 plus 240, okay, we were getting the overflow. 361 cannot be adjusted inside the unsigned int. Okay, so we will not get 180 basically, right? Now I will show you the solution in which I will get the 180 without any overflow problem. Okay, so basically there should be some another type of calculation for this mid. Okay, I will not do low plus high by 2. I will do something else. So let's see how. So basically we are actually finding this 180. Okay, so basically 180 is the midpoint of, you can say, 121 to 240, right? So basically between 121 and 240, how many number of elements are there? So basically to find this, you can say 240 minus 120, right? So it will come as 119. Okay, that means you can say the 119 is the total length, okay, of 121 to 240. Okay, and these number of elements are present between 121 to 240. Okay, this is the total length. Okay, now if I do half of this 119, okay, half of 119 will be 59.5. Okay, and if I take the floor of this, so it will be 59, right? So basically 59 is the, you can say, half of this total range, half of 119, that is this one. Okay, now if I want to get 180, then what should I do? Then in 59 I should add this 121, right? So I will get what? I will get actually 180, and this 180 is the mid value that I actually want. So basically what I have done, I have done this calculation to find the mid, low plus high minus low by 2. So basically if you see this example again, so basically your low was 121. Okay, and I was saying, okay, instead of adding 240 plus 121, okay, which was giving me 361, and then you can say you are taking the half of this, just do one thing, you decrement, you find the difference of 240 and 121. Okay, 240 is the high value, okay, and low value is 121. You find the difference, okay, and you take the half of that difference. Okay, so 240 minus 121 will give you a smaller value. Okay, it will give you a smaller value less than 240. Okay, that is 119, and 119 can easily be accommodated inside a unsigned int data type, right? Okay, and then if you take the half of that, okay, it will again be a lesser value than 119. Okay, and that was 59. So 121 plus 59, it was giving you 180. Okay, the basic idea was, instead of adding these two numbers, okay, you just take this difference. Okay, from 121 you take this difference. Okay, and this difference can be easily calculated by first finding the difference of this range, okay, divided by 2. Okay, so that your total answer, okay, this total 59 answer can easily be accommodated. And before that, if you find the difference, okay, it can easily be accommodated inside an unsigned int data type. Okay, so the funda is, by adding two large numbers you will get a very large number. Okay, by finding the difference of the, let's say, two large number also, let's say 240 and 121, you will get a smaller value. And okay, and a smaller value will not give you a overflow problem. Okay, so yeah, this was the main point in solving the problem of the overflow in binary search. Okay, so this is the, you can say, this is the line that you can see in many of the questions or implementation on the internet also. Okay, and this is very famous problem that can be asked in your interviews also, that what is the solution of the overflow problem in the binary search. Okay, and this idea you can use in any of the other interview problems also, where you are finding the overflow problem. Okay, so in summary, we can say we can avoid this mid calculation, okay, by taking the large data type. For example, instead of unsigned int mid, we can take the long data type, unsigned long int. Okay, or if we are like getting the overflow in this type of data type also, let's say our array is also again very large, we can take unsigned long int type also. Okay, and the second good way is, along with this large data type, we can take this calculation into our implementation. So by taking the large data type and along with we can use this calculation, we can avoid the overflow bug problem. Okay, and just to tell you, this calculation, okay, is basically equal to this only. Okay, you can say if we take the LCM of this, okay, it will be 2 into low plus high minus low by 2, and if we solve this, we get this. Okay, so basically this calculation and this calculation basically are giving me the same result, but when we will implement, okay, then as programming language or the compiler goes, this calculation can give us the overflow due to the range of the various data types. Okay, due to the limitation of the various data types. Okay, due to the limitation of the ranges of the various data types. Okay, now before ending this video, let me ask you one practical question. Can we actually create a big size array, for example nearly size of 2 to the power 31? Okay, that is, can such type of problem of the overflow occur in real life systems? So basically, if we want to create an array of, you can say, 2 to the power 31 elements, so that will require 8 GB of memory. Okay, how? So let's say if your integer is of 4 byte, okay, so 2 to the power 31 means 2 to the power 30 into 2. Okay, and if each element is of 4 byte, that means these all elements are of 4 byte. Okay, so 4 to the 8, so basically this is 2 to the power 30 into 8 bytes, right? So that means 8 and 2 to the power 30 is giga, so it is 8 GB. So basically, if you are creating an array of 2 to the power 31 elements of integer types, okay, and those are of 4 bytes, so it will require 8 GB of memory. Okay, and in our real life system, okay, we can have like 8 GB of memory. Okay, or you can, let's say, you have a, or you can say you can have a system which can have more than 8 GB of memory also. Okay, so that means we can create, okay, or we can have, okay, these type of big large size arrays. Okay, so if we talk about the Java language, then yes, you can create the big size arrays. Okay, so that means overflow condition can occur, right? Now in C and C++ language, you can create this big size of the array. Okay, but you cannot create on the stack because the default limitation or default size of the stack is nearly 1 to 8 MB. Okay, so this size of the like big array you can't create on the stack, but yes, it is possible to create this array on the heap. Okay, so that means if you can create this big size of the array, that means again overflow problem can come. Okay, so that means you need the solution to avoid the overflow bug problem. Okay, and lastly, all the divide and conquer algorithm like merge sort, okay, which actually calculate the mid value. Okay, so they are vulnerable to this kind of bug problem. Okay, so that means while you are calculating this type of you can say mid value, okay, in any of the divide and conquer algorithm, please take care of this thing, that you do not go into the overflow problem. Okay, and avoid such type of problem, okay, to make your systems safe or to make a program safe. Okay, So yeah, this was all for this video. If you have any question, please write down into the comment box, and I hope you have understood the gist of the overflow bug problem in the binary search. Do like, share this video, comment on this video, and subscribe the channel and press the bell icon for notification of the videos. See you in the next video. Till then, goodbye.